The next project presentation, we have Alish Dipani, who is joining us online and who will present his project. He was working on a project with the title Bringing Magix Weather Maps to Matplotlib. His mentors from ECMWF were James Vandell, Stefan Siemen, Baudouin Raoult, and Sylvie Lamy. And James will give a short introduction on the motivation and the aims of this project. And then Alish is joining us today from Boston, and he will share what he has been doing the past 4 months. So James, the floor is yours.
So this project was all about, as Julia said, bringing Magix plots to Matplotlib. So for those of you who don't know, Magix is the primary geospatial visualization library that we use at ECMWF. It's a C++ library that produces high quality weather maps and charts for both the web and for print publications as well. It's a very mature and feature-rich library with, it can produce loads of different types of weather plots. And because it's an internal library, we have control over adding new features, all those sorts of things. It's very widely used internally and also by some of our member states. And it does have a Python API called Magix Python, which offers all of Magix's features through a Python API, but the API isn't particularly Pythonic or familiar to external users who aren't familiar with our libraries. And meanwhile, at ECMWF, we have a new software strategy, which is all about trying to embrace open source software and engage with the open source Python community, which involves developing new open source tools, lots more Jupyter-based interaction with our data, and also offering high-level libraries built upon sort of modular stacks of specifically targeted Python libraries. And when it comes to plotting geospatial data, the most widely used libraries in the scientific community are Matplotlib and cartopy. They're very widely used and familiar to a lot of different users, compatible out of the box with Jupyter notebooks. And they're also mature libraries with many features, although they're not specifically targeted towards weather and climate maps. So the idea of this project was to try and gain all of the benefits of the very familiar Matplotlib API that a lot of users are familiar with, while also taking advantage of the maturity of Magix and all of the great features that it has as well, by sort of plugging Magix into the back end of Matplotlib and cartopy, and hopefully gain the best of both worlds. So Alish will talk about that. So over to you, Alish.
Thanks a lot, James. So hey everyone, I'm Alish Dipani and I'm from India, but currently I'm in Boston. So I'll be talking about my project bringing Magix weather maps to Matplotlib. But before starting, I wanted to thank my mentors and Esperanza and the team for such a wonderful job at mentoring and arranging everything and making sure that everything goes smoothly. So thanks a lot. And thanks, James, for the introduction. So the outline of the talk will be, first I'll again give a brief introduction, show some previous examples about the state of the library that was before I started the project, the motivation in the aim that we had, our deliverables, a short demo, and a final conclusion. So to introduce, as James said, Magix is a meteorologically oriented graphical library using C++ for visualizing meteorological data on different projections of the globe. So you could have this at different projections of the globe. You could either show the whole globe or some specific area or any specific format that you want. But since it was written in C++, it might not be very accessible to all the users. So Magix Python was created to provide a Python interface to Magix. And the way in which it works now is that you have the internal library Magix, which is written in C++, but we don't need to interact directly with Magix. Instead, we interact with Magix Python. So the macro submodule in Magix Python, we give it the grib or netcdf file as an input about where to plot what we want to plot, and the figure components such as coastlines, contours, or anything that you want to plot. So the macro submodule takes this as an input, the place where you want to plot and what exactly do you want to plot. This Magix Python processes this in a format that Magix can understand, and Magix processes this and outputs this in a binary format. But you can't directly plot this binary format we can directly plot this as an image, but it's not fully customizable. If you just plot it as the binary format, it will just be an image, such as a PDF file or a PNG file. Instead, what Magix Python does is that it takes the binary format, it understands the format using a binary driver, And we implemented a function called Matplotlib plot, which basically converts this binary format into a Matplotlib format in a more Pythonic way. And this Matplotlib plot function takes in a Matplotlib figure or a car2pi projection. So you have the control of where to plot this plot. You can give any Matplotlib axis or any car2pi axis that you want to plot, and Magix Python plots it on the plot that you gave it to it. And the final output is a PDF or PNG file. But the takeaway here is that since you are giving the Matplotlib figure and the car2pi figure, you control all the properties of the plot, such as maybe the title, the size you want, maybe you want multiple plots. So since we control the overall plot, we just tell Magix to plot at a specific location. So that's why it's fully customizable and you can extend it to anything. Okay, so just to give some previous examples, this is how Magix looked, which is a pretty neat plot, but Magix Python was not fully developed, so it had a few inaccuracies. So we worked on improving Magix Python and integrating and making it more Pythonic and bringing it to Matplotlib plots. So again, the motivation was to utilize the power of Matplotlib to make plots more customizable and interactive. And since most of the Python community mainly uses Matplotlib and car2pi, we wanted to make it accessible to all the users. And we wanted to provide an easy to use high-level Python interface for users. So the aim was to extend the binary driver to convert the output from binary format to Matplotlib axis object or Matplotlib format. And finally integrate Magix with car2pi to provide all the flexibility that you want. And this flexibility should be very easy to use. So car2pi does that. So the deliverables were as follows. We plan to update documentation, make syntax more Pythonic for it to be very easy for the users to use, and improve the aspect ratio, improve text, improve setting plot limits. And the bigger deliverables were implementing passing a custom Matplotlib axis for you to control everything on the axis, and add a color bar, which could be either discrete or either be continuous. And finally, integrating Magix with car2pi. Okay, so just to give a short demo. So this is how the plot looks now as compared to the plot earlier. So we have improved the aspect ratio such that the aspect ratio is always preserved. Even if the user tries to change the aspect ratio in a certain way, we don't want the figure to get distorted because this is a geographical figure. So we always want the aspect ratio to be correct. That's why we improved and controlled the aspect ratio. We improved the text as well because earlier there was some text appearing on top of the figure. We removed that and integrated these ticks or these labels into the Matplotlib figure itself so that we don't have to plot it separately. So instead of earlier, what Magix Python used to do is that plot the figure, plot the binary formats figure, and then plot the ticks on top of that figure, which would sometimes overlap with the axis, especially if your size of the figure was too small. But instead, we pass these ticks or these labels to Matplotlib directly so that Matplotlib itself can plot this so that it looks very neat. And finally, improving setting the plot limits, because sometimes it might happen that your plot limits are not incorrect, so it might only show a part of your figure. But we improved this so that all the part of the figure is preserved and the aspect ratio is preserved. Okay, so this was about the general improvements in plotting the figure. So finally, coming to the bigger deliverables, we implemented passing a custom Matplotlib axis. That is, you get to control everything about the plot. So Matplotlib gives the axis all the properties of the plot. Magix just takes an area from Matplotlib and tells it to make my plot here. So with this, you can control everything. And that is to say that, let's say if you want multiple plots, in this example, I made a Magix plot as well as a Matplotlib plot in the same figure. So this is the same figure. You could do the same by having a Magix figure here and a Magix figure here. Or if you want, you can even combine both of them. Such that, let's say you have a Magix figure here and you wanted to plot some specific points using Matplotlib. you could even do that because everything now is customizable. So we implemented passing a custom Matplotlib axis. And we also added a color bar, which used to appear on top of it, but the Python way, the way in which we added a color bar is that instead of taking the space from the figure itself, such that the figure could be squished, instead what we do is we actually extend the figure to some length, and we make a new axis here. And on top of that axis, we make the color bar. The color bar is just a heat map showing which color corresponds to which temperature. And in this example, this is discrete. So you could have either bins of color bar. Let's say you want to say that 30 degrees Celsius to 35 degrees Celsius is this color, 20 to 25 degrees Celsius is this color. So you could make a gradual color bar, which could be discrete, or you could go for a continuous one. Sorry, I think my presentation crashed. Yeah, sorry for that. So as I was saying, you could either go for a discrete color bar, which could be either bins of different temperatures, or it could be a continuous one, such that you say that my whole range is, let's say, from minus 45 degrees Celsius to maybe 35 degrees Celsius, but you want to plot the labels at certain intervals. So here we plot it at 2.5 degrees Celsius intervals, but the whole color is gradual for it to have a more continuous feel. So this was adding the color bar part. And finally, integrating Magix with cartopy, which gives you control over all the things in the figure. So in this example, I plot a simple plot, Magix plot, but I also added a simple scatter plot to point just specific points here. So the beauty of integrating Magix with cartopy is that you could change this format, change the whole figure, but the plotting would still be consistent across different formats. That is to say, for example, here I'm plotting a geospatial plot, but if I wanted to change the format to, let's say, a whole globe, so I could do that just by changing a simple setting, and Magix and everything will work. These plots will be mapped onto a different format, such that you still see that these scatter plots are still at the same location that we wanted to present, and the locations are not getting distorted. So this helps you with controlling the format of the plot you want and changing it however you want. So you could take a simple plot from somewhere in some format, you could change the format of that. And just to give one more example, you could have changed it to a whole globe as well. So you can easily transition between different formats with cartopy. And you don't have to worry about Magix getting the plot getting distorted, because cartopy handles everything. Magix just tells cartopy to plot, where to plot and how to plot. Cartopy handles the actual plotting part. So this was the major deliverable. So in conclusion, we improved the Python interface for Magix, that is Magix Python. So it is now fully functional, and we made Magix figures fully customizable using Matplotlib and cartopy to give the user ease to use and all the flexibility that they want. And finally, we also added documentation. Thank you.